Our next lesson is about constructions. We talked about constructions earlier in the year, but there were two constructions that we didn't talk about that we need to address that are in our CCRSM standards. And now that we've talked about proving triangles congruent, I wanted to revisit at least two of these and talk about why they work using triangle congruence. This lesson will cover one CCRSM standard, and that is to show constructing a line parallel to a given line through a point not on the line, and constructing a perpendicular line other than the perpendicular bisector. Now, this lesson is not in Engage New York, and so I will ask you to get out a piece of notebook paper and to take notes on that, and then put that in your binder, let's say before lesson 28, so that you will have some notes from this lesson to use as we talk in class. Let's get started. First, we'll talk about how to construct a parallel line through a point. And I like this website, hopefully, as I use these videos, that this website's still up and running, but it's mathopenref.com. It has really nice step-by-step instructions on how to do constructions. And so we start with a line and a point not on the line. We'll next draw on a transversal. Okay, so what we're actually doing is we will be constructing congruent corresponding angles. So we look at this angle right here, angle QJR, this angle, and I will construct a congruent triangle up here with vertex R so that they're corresponding. So I'll start by drawing an arc and drawing the exact same arc over here. I will then measure the length of the arc and copy that length. And then I will simply connect R with S, and that line will have to be parallel because I've constructed two congruent angles and their corresponding angles, and we've learned that when the corresponding angles, then the lines must be parallel. Okay, now we'll talk later on in this video why that construction of congruent angles works. For at least now, that's how you construct parallel lines. And we'll practice more of that in class when you have compasses in your hand. The other construction to talk about is a perpendicular line from an external point, so a point not on the line. The first thing you do is to draw an arc that'll go through the line twice. Now this construction does it separately. I usually am lazy and just make one big arc. So I'm going to pick up my compass. Now hopefully you see between P and Q I have a segment. And if we find the perpendicular bisector of that segment, then we have found a line perpendicular to R through the line. So this has you just draw one mark and one mark. And that's because we know the other intersection will be at R. But I like actually going through R, going the whole way, so it's the exact same construction as before. And then I draw my line. And that is a line perpendicular to the given line that goes through point R. I next want to talk about some of these constructions and why they work using congruent triangles. First, we'll talk about constructing congruent angles. And we started off this by constructing this arc and then the exact same arc over here. And then we measure the length of this arc and then copied that length over here, and then drew our line, and that we said that the angles then were congruent. Now to make this easier, I'm going to label some of these points. Okay, now when we constructed this, because I used the same arc for AB and AC, they must be congruent because those are both radii of that arc. And then I said don't change your compass when you went over and put the point in on D and then drew the second arc. And so AB must be congruent to DE because the compass was the same length. And similarly, DE and DF must be congruent because it's the same arc. And so these four segments must all four be congruent because I didn't change my compass. Now, one thing that I didn't tell you is that there is a segment, or you can think of a segment right here connecting BC and EF. And now when you measure the length of the arc, you're measuring the length of BC. And then as you drew that line to see where it intersects, you're constructing congruent segments. And so BC must be congruent to EF, and these two triangles must be congruent by the side, side, side triangle congruence criteria. Now, once the triangles are congruent, I know that all the corresponding sides and all the corresponding angles are congruent, specifically angle A and angle D. And that is why this construction works for constructing congruent angles. The next one we'll look at is bisecting an angle. And again, we start off by drawing an arc, and it didn't matter how big or small your compass was at this point, you just drew an arc, and then put the pointy end here and drew this arc, and the pointy end here and drew this arc without changing your compass between those two steps. And then we drew a line through the middle. That was the process. Now, why that works, I will label a few of these points to make it easier for myself. All right, when we drew our first arc, we are constructing it so that AB and AD are congruent because they're both radii of that circle. Now, at this point, you could change your compass, but we have actually a line here and a line here. And as I drew in one of those marks, I then drew the exact, without changing my compass, I drew this other mark, so these two are both congruent. Now, AC is congruent to itself by the reflexive property. And so these two triangles, ABC and ADC, are congruent by the side, side, side triangle congruence criteria. And if they are congruent, then all the corresponding sides and the corresponding angles are congruent. Specifically, BAC must be congruent to DAC. Okay, so what that means is because angle BAD is being cut into two parts, and those parts are equal, that means it's being bisected. And this is why this construction works for bisecting an angle. In this lesson, we talked about constructing parallel lines and perpendicular lines, and we also used triangle congruence to explain why bisecting an angle and copying an angle worked. Thank you for watching.